Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. If you've been keeping up with my videos, then a derivative of a logarithmic function should not be a problem for you, even if you don't have a rule. And here's why. We know we can take y equals log base b of x. Okay, I'm going to rewrite it in exponent form. So b to the y would equal x. And I'm going to derive. This is assuming that you know how to use the rule for the derivative of something to a power as well as a chain rule. So if you haven't watched those videos, you might go back. Okay, so the derivative of this, right, would be b to the y times the natural log of b. And the derivative, well, and then you have to chain rule, so times the derivative of y, which is 1 y prime. And on this side, we'd have the derivative of x, which is just 1. So let's solve for y prime. Y prime is going to be 1 over b to the y times the natural log of b. Now recall that b to the y was x, so y prime equals x times natural log of b. Okay, so let's go back here and look at this. Y prime equals x multiply, 1 over. I forgot my 1 over there too, didn't I? I need some more morning coffee. And obviously the base has to be greater than 0. We have a rule now. Can you see where it goes from the beginning? Do we have to do this all every time, or can we use the rule? Absolutely, if you know the rule, do the rule. Well, what if it's just natural log? Okay, let's try that. Y equals the natural log of x. Well, that would be the same as log base e of x, right? So the derivative, according to the rule, is 1 over our x value times the natural log of our base. Well, the natural log of e is just 1, so we get 1 over x. So can this rule work for natural log? Absolutely. The derivative of natural log of x is 1 over x. Okay. Why isn't it so simple for other bases? Well, only e and natural log work out simply. So I have that rule sheet. I'm going to go ahead. I've used it a couple times. I'm going to add to it. So the derivative of natural log of x is 1 over x. The derivative of other bases, right, is 1 over x multiplied by the natural log of that base. So a little extra work for bases non-e. Okay, so let's try that out. Let's get my paper moving here. My papers are all sticking together today too. Y equals the natural log of x squared plus 5x minus 4. Okay, so the natural log is a simple one. I don't have to do the extra work because the natural log of base e is just e, or is just 1. So our derivative, 1 over what's inside, times the natural log of our base, but our base is e, so times 1. But don't forget that we have to chain rule this. So we took care of the derivative of the natural log, but it had something inside, so we need the chain rule to pop in here, so times 2x plus 5. And that's going to come from the chain rule. So our final answer for our derivative would be 2x plus 5 divided by x squared plus 5x minus 4. Okay. What about y equals 3, the natural log of 3 to the x plus 1? Okay? So y prime, that rule is 1 over what's inside. I don't have to worry about anything extra here because it's a natural log. Multiply by the derivative of what's inside. But to derive 3 to the x, it's 3 to the x times the natural log of 3. And then the derivative of 1 is 0. So we'd have 3 to the x multiplied by the natural log of 3 over 3 to the x plus 1. Okay, now we're going all in because you've got to see scariest environment imaginable, right? F of x equals the natural log of x plus 1 over the square root of x minus 2. Okay. Well, if I were to do it right now, I would have to do the natural log 1 over what's inside multiplied by the derivative of what's inside. So low d high minus high d low, and that would be 1/2 x minus 2 to the negative 1/2 times 1 all over the low part squared. So we had a chain rule, a quotient rule, well, the log rule, right? The log rule required a chain rule, required a quotient rule, which required a chain rule, and then we got to try to simplify all that. Blech. We're not gonna do that, folks. Okay, we've got to go back to some of our algebra skills because we can expand logarithms. So if you remember, we can rewrite f of x as the natural log of x plus 1 minus the natural log of the square root of x minus 2, which then can be further rewritten as the natural log of x plus 1 minus 1/2 natural log of x minus 2. And then we can derive that by doing 1 over what's inside multiplied by the derivative of what's inside minus 1/2 multiplied by 1 over what's inside times the derivative of what's inside. I don't know about you, but that was a lot simpler. Now, could we get a common denominator and go with all that? Yeah, but it's beats having a double fraction and then having a quotient rule with a chain rule inside of it and everything else together. Like we had fractions here, we had radicals here and there. Let's just expand these logarithms and make our life easier. Okay? Y equals log base 3 of x squared minus 5. Okay, this time we don't have natural log, so that does throw a little extra wrench in our gear, right? So y prime is going to equal 1 over what's inside multiplied by the derivative of what's inside, but you also have times the natural log of the base right there. And that's all you have to do. So not so bad, right? Okay. Let's say you have this problem. And you have to find the derivative. Well, you could do the quotient rule, low d high, but when you did the derivative of high, that's a product, so you'd have to do a product rule. And then inside that product rule would also be a chain rule because of the square root. Then minus high d low, which would also have a chain rule, all over the denominator squared. That's a lot. That is a lot, a lot, a lot. So what we can do instead, so we can say, look, I don't want to work with this. That is just way too much, and it's not fun. So I'm going to just log both sides. In fact, not just log to make my life really easy, I'm going to natural log. And you might be going, but I avoided logarithms in algebra because I didn't like them. Well, for deriving, you're going to like them because it's going to make your life easier. So let's expand this. So we'd have the natural log of x instead of the power of 3/4, so I'm going to move it out front, plus the natural log of x squared plus 1 instead of the 1/2 power, I'm going to move it out front, minus the natural log of 3x plus 2 instead of the 5th power, I'm going to move that out front. Okay, so I rewrote it. Now I'm going to derive it. 1 over y times y prime. Notice the y prime method popping out there? Yep. 3/4 times 1 over x times the derivative of x, which is 1, plus 1/2 times 1 over x squared plus 1 times the derivative of that, which is 2x, minus 5 times 1 over 3x plus 2 multiplied by 3. Okay. Carry on, have a run on paper, right? So that gives us 1 over y prime equals 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. So y prime equals y times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. There we go. We didn't have to do a bunch of chains because we used our logarithm. Now, can we take this y and substitute back in what y was? Absolutely, that is an option. Do we have to? No, we don't have to. So anytime it's looking like a super complicated derivative that's going to have lots of rules in it, you can just natural log both sides and then expand your logarithm and then derive. Can save you a bunch of headaches and some sign errors and things like that over just powering through. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.